Hey, what's going on, guys? WukongJS here. In this video I'd like to demonstrate how so-called null move pruning technique works while being applied to alphabet search on the example of my JavaScript chess engine I'm currently working on named Wukong. So without further ado, let's actually go for a little demonstration. So here I have my null move pruning code. Let's consider it as a black box at the moment. I will just command this code out from my search and run the search without null move pruning being enabled, and then I will re-enable it. And just to give you an idea regarding the difference of the saved nodes. So let's update the page. To make this changes come into life. If you would be cloning this engine and trying this kind of like at home, make sure to disable this cache in the network tab in order to make all the changes occurring within the JavaScript source file being applied to the current version you're currently working with, because otherwise that would be a little bit confusing, like why the changes you're making are not being seen in the page actually. So I will use the API call here to, because I could have clicked this make move button, but it would be searching for a number of seconds, so 1 second in particular, and it's not always searching the same because my video recording software working and so on, so it's not that good result. So instead I just would be searching for a fixed depth to make sure that the number of traversed nodes is the same regardless of anything basically. So let's have a look. So here we have the depth 6, and it's already starting to kind of being a little bit laggy, and at the very end we have 1,030,000 and blah 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 nodes, so it's kind of 1 million nodes here. And now let's see what happens if we will apply our null move pruning. So just save this here, and again, like, just update the stuff, set the position. It's seen on the compositions like the initial one, but it's more dramatic change. There are kind of like more dramatic changes when the position has lots of captures inside. So I will now run this search again, and suddenly instead of 1 million nodes we have 733 nodes, so it's kind of reasonable number of nodes being sliced, while the principal variation remains the same. So this was the demonstration regarding how the null move pruning basically works. And now let's simply have a look at the source code and what in particular we're doing here actually in order to obtain this sort of an optimization. So as I've been describing many times before in this channel, and everybody who does chess programming actually knows that the matter of fast search within the chess engine is the matter of how to say this, how fast the so-called beta cutoff occurs during the search. So the faster beta cutoff occurs during the search, the less garbage we're searching during our search basically. So it's all the matter of, and again, like the very initial technique to make beta cutoffs, this it's also known as the node where the beta cutoff occurs is known as the fail high node. So in order to reach so-called fail high node as soon as possible, the very first and probably the most important technique is move ordering. So we need to make sure that we calculate captures first, because captures are most likely about to be producing some fail high nodes followed by the beta cutoffs respectively. But there are many other techniques like actually it's not the matter like if there are many or not many. One of the techniques that tries to make this beta cutoff a bit earlier compared to where this beta cutoff happens in the natural flow of the search. So one of such technique is called as a null move pruning. So if we don't have a look at this part, which actually does the null move pruning. Well, actually, it's not the null move pruning. It makes null moves and takes them back. But if we just have so this line is just a matter of timing, just to stop engine from calculating what the time is up. So it doesn't regard really not regards to null move pruning. But this one, if score is greater or equals than beta, then we just want to return beta. This is exactly the same line as we have in our main search. So the most interesting kind of like idea behind this is the concept of the null move itself. So I don't know, probably you know, like I've been reading lots of things about null move pruning, and I don't know, probably due to the misunderstanding, because in English it might be a little bit different than in my native language or something, I don't know. But until this day I really didn't have that clear understanding of what the null move pruning is, of what the null move is. And you know, like if you understand what the null move is and what they mean by saying null move, or in better words, we call it like pass the move. So we're not making, we're just passing the turn to the opponent. And again, like now when I do understand this seems very trivial, but before I had that understanding, a null move pruning technique was complete mystery to me. So let me just try to demonstrate one little example here. So first, I just want to disable the think function in my chess engine. So I would be able to, so if I just start moving pieces, it would be kind of like making moves in return. So I just want to avoid that behavior. For that reason, I just want to say function think equals to nothing. Okay, just redefine the think function. So now it would allow me to just move the pieces, and I can undo moves as well. So it would allow me just to move the pieces and demonstrate what I want to demonstrate instead of just playing chess. So by the way, one of the tricks regarding this Wukong JavaScript chess engine that you can do, you can just simply switch it to the mode where you can just move the pieces on the board, and you're not allowed to do illegal moves, so only legal moves are allowed, and you can take back. So if you want to demonstrate something, that's another use case for this chess engine. So without further ado, so null move, okay? So let's say this position we have white to move, and some of legal moves might be like this, I don't know, like this, sorry, like this, whatever move. And this is the normal, the natural flow of this route. But the null move is the situation when we say, okay, now it's white to move, but we actually want to allow black to move first. Well, obviously, assuming that the current implementation won't allow me to make the null move because it's kind of illegal in chess, and this implementation validates all the moves. I don't know. Probably I could have make an API. I could have added the make null move to the API to allow kind of like demonstrating this stuff. I don't know, probably. But you just imagine that. Well, maybe I can just hold on a second. I'm just wondering, can I disable the validation in an easy way? Probably I can. Okay. But anyway, make a null move. It's literally just change the side without moving a piece. That's the very gist of it. So we also need to take care of the board state variables like hash key and peasant square, 50 rule move counter, castling rights. But in essence, the matter of making a null move is actually not moving a piece at all, but just simply switching the side, swapping the side. That's it. So in this position, let's say we don't make a move, but we just swap the side, and now it's black to move. Okay? So, well, actually, I just found a hack how we can do this. Yeah, I've just realized how we can do this. So let's consider the FEN, and let's say we just switch color to black and set again, and now it should be allowing me. Yeah, this is the easy way of how we can achieve this. Yeah, finally I found a way how to demonstrate. And now we can make a move for black. And now we can again like make some search, whatever moves we need. And the idea here is that the search that we're making, we still can undo the moves, right? And when the search is over, we just restore the side back to white, and we keep playing our game already kind of from this position. But the idea is that during this kind of like, let's call it null move search, maybe not the most scientific search, but still. So if we're searching after giving black, in this case it's a matter of giving black another kind of move and another turn to move. So it's black did move before, but we say like, okay, black, you just make another move. And when we're searching in this sort of way, it most likely would, like it happens in the natural search, it would be producing some beta cutoffs as well. And in this case, we can use beta cutoffs from the assumption that we're not going anywhere, but we're allowing black to go. Based on that assumption, that they call it like in every position, we can say that making whatever move is at least better than not making any move. Well, obviously it's not true for Zugzwang, but that's a bit of a specific situation that I'm not gonna be covering at least now, because I just don't really want to overwhelm you guys with this specific stuff. From the practical point of view, I can say that I've used this making null move in every single case, in every single search, without getting bothered regarding this Zugzwang, and it's kind of working quite pretty nicely for now. Well, obviously, probably later on, when I would be a bit smarter compared to how I am now, I'll probably wrap this null move prun into some sort of a conditionals. But at the moment, I can say that it's okay to use null move pruning without any conditions, literally every search. Well, we have a couple of conditions, but I'll cover this a little bit later on. So let's say we just swap the side here, right? Okay, can I go to end? Yeah, let's say we've swapped the side, making some sort of a search, and then we just restoring the position back, and then we take in null move back, so literally restoring side back to white, and already we have lots of cutoffs occurring within the search, and that's how we slice this. That's how we slice those nodes from the overall number of traverse nodes or positions, or while having absolutely the same principal variation. Well, I can guarantee that principal variation will always be the same after the null move pruning. It's a good question, and I'm not that kind of like proficient in chess programming to answer 100%. Is the principal variation always going to be the same or not? Because it's not that trivial to ask, to be honest. But anyway, the idea is that, well, I think that they said it somewhere that there are some possibilities to overlook some good options during null move pruning, but still it's quite pretty safe enough to be used every time within the search. And also I read in chess programming Wikipedia that actually the null move pruning is something that so like earlier engines didn't consider to make it all the time, but was making it conditionally, while in modern era they more like making this null move every single search. Well, again, it depends from one engine to another. It might be different, but I just want to say from the practical point of view, from the perspective of my experience, I've been using null move pruning without any conditions, just straight ahead every single search, and at least it's not leading to blundering pieces or some horrible disaster like that. So it's just another search optimization techniques that kind of works. Okay, so with these ideas in mind, let's now walk through the source code quickly, and that would be it. So we need to make sure that the search ply is at least equals to 1, assuming that it starts from 0, so not in the root node. We don't want to make null move pruning in the root node, so at least one node ahead from the root node. the parameter, so depth greater or equals than and the number, and this the sum of these numbers should be respective. So if here we have, say, 3, then -2 -1 -2 would be -3, so it's okay. So say here we would have -1 -3, it would exceed the depth and engine won't be working. So traditionally people use, so this number is called reduction limit, if I'm not mistaken. So or reduction constant. So that's how we reduce the depth. So we're not just saying depth -1 like we usually do, but we're reducing the depth by 2, and also people reducing the depth by 3 as well. So I didn't hear about some different numbers for reduction, but these 2 and 3 are most popular. So this null move pruning is a little bit more aggressive because we started earlier, and in my experiments I had this depth greater or equals than 3 and reduction limit equals to 2, slicing more nodes compared to, we say, depth greater or equals than 4 and minus 3 respectively. But maybe the number of positions I've been testing this within is not that big enough, so I don't really want to claim that this is better than saying have depth greater or equals than 4 and depth -1 -3 rather than this implementation. This is just something that I came up with in my experiments, and something that I really like how it works. Anyway, we need to make sure that these numbers are equal. So -1 -2, it's kind of 3. Absolute value is 3, and here a depth 3. So if here we say 4, it would be like -1 -3. So I hope that's clear. And also we don't really want to make null move pruning when it comes to a check. So instead, when we have our kin being exposed into check, we're using so-called check extensions. So there are kind of 2 things that we can do with our search, is to extend the search and to reduce the search. The matter of extension is when we increasing the depth, and the matter of reducing is when we decreasing or reducing the depth. So we don't really want to reduce the depth in case when we actually want to increase the depth. So in case of check, we want to search more because we need to make sure that we're not getting into the mating traps and things like that. So we're not using null move pruning when kin is getting exposed into a check. And this is the most simple condition to consider null move pruning, the most simple ever, probably the most minimal one. Again, like probably one day I would extend it a little bit, but my current understanding of null move pruning, again, like this is my current understanding of null move pruning. And again, like as I've been mentioning in the previous videos already, so I realized that chess programming is just a matter of fighting my stupidity, to be honest. So I'm just trying to rediscover these methods I've been using many times before, but trying to understand them deeper. And as far as my understanding kind of grows, I'm trying to share this understanding with you guys. So maybe this would help for some of those who are kind of beginners in chess programming. So with this idea in mind regarding the reduction, the very last thing, and probably the most important and the most mysterious thing to me, to be honest, which I didn't really understand for kind of long time basically, is the matter of what is the null move. What does it mean to make a null move, and what does it mean to take the null move back? So as I've been demonstrating this already in the GUI, so just a matter of not moving the piece but simply changing the site and then restoring the position back. But assuming the current particular implementation of my chess engine, let's have a look how this kind of works. So a few words regarding how the move generator works, for those of you who's not aware of that. So I have incremental updates for board position and piece lists. So all that regards the chessboard position, like moving pieces, taking pieces, and so on. That's all the matter of adjusting the position. And this is done in the manner of incremental updates. So if we have a look at the normal make move and the normal take back function, we see here that we actually handle all the moves, like moving pieces, adding pieces, clearing pieces, etc. While in the null move, we're not actually moving pieces, as been described already. So it's just a matter of changing the site. So the gist essence of null move pruning in this line, we're literally just changing the site. All the rest is just the technical stuff. So what happens here? So in my implementation, I'm using the move stack that uses that keeps track of the board state variables. So I don't need to incrementally update the board state variables in the takeback function, but instead I can simply restore them from the from the last element of the move stack. This is how I calculate the last index of the move stack. So site to move and peasant square, castle in right, 50 rule move counter, and the hash key unique position identifier all are being pushed onto stack. Well, if this is the matter of a normal move, we also push the move to restore the position later on and the captured piece, if any. But assuming that this is a null move, and this is very dramatic stuff here, so we just use a null for a move and null for a captured piece. Not all the chess engine has this. I don't know, probably synthetic sugar is not the right word, but I think you understand what I'm talking about here. So the idea is that as far as we're not moving any pieces, there is no need to store a move because there is no move made actually on the chessboard. So it's just a matter of changing the site basically. And now the interesting thing that just to make sure that we're dealing within peasant hashing correctly, we need to hash and peasant if it's available to make sure that null move pruning is kind of working properly. And also we're setting to 0 to like no in peasant is not 0 value. It's not the 0 value. It's 120 value. In my case, this is the off-board value. So it's not. This means that in peasant is not allocated on the chessboard. So this means that we're resetting the in peasant, resetting the 50 rule move counter, because within this null move search we don't really want to affect the 50 rule move counter. And then we're switching the site and hashing the site. And then when it comes to restoring the board position, we're simply taking all the board state variables from the stack, popping the stack, and we're done. Very simple and straightforward, and relatively fast, I need to say. So that's very simple stuff. So the most essential line in the entire make null move function is literally just changing the site. All the other variables, well, obviously if we're now doing this and this, then the position would get malformed and it would no longer be producing valid moves, which is a total disaster for chess engine. But again, like just wanted to point out the gist essence of what's happening in the null move, which I didn't understand before. It's just a matter of changing this site. So very simple, just changing the site, then making search with a reduced depth to find where beta cutoffs are most likely to occur. And then, so let me just go to null move pruning back. And then when the beta cutoff finally occurs, instead of making the entire search here, instead we just return this beta straight ahead. And that's it. So we're just saving many iterations of the search. And I also need to say that the deeper we go, then the more number of saved nodes would become basically. So we've been testing this with a depth 6. It might not be that significant compared to it's not that position I meant. Sorry guys, I meant this one. So here there was around 1 million without the null move pruning, and it's only 773 thousandths with the null move pruning. But if we go to depth 7, depth 8, 9, 10, etc., the number of saved nodes would be very big. So null move pruning is known as the technique reducing the branching factor significantly, and respectively, like we know that the branching factor is growing. The deeper we go, the more branching factor is growing. So making use of null move pruning is just a matter of it's trying to avoid that branching factor to grow at the deeper depths. So that's a very simple idea behind it. So I think this is it from my side, guys. I'm sorry for it's maybe probably a bit too on the surface understanding, not that deep regarding the null move pruning, but you know, like even the simplest search optimization techniques ever possible, no matter if these are the search optimization or other techniques, you know, like every time you're coming back to a specific technique, at least for me personally, it happens that I'm starting to understand current given technique better every time I'm getting back to that. And also when you're making a video on that, it helps understanding as well, believe it or not. So that's kind of it. Okay guys, so this is it from my side. I hope you've enjoyed the video and hopefully learned something interesting out of it. Until the next time, and take care.